Good morning, colleagues. Good morning, learners. I'm Jaapie de Jager. I'm the acting SES for Civil Technology Woodworking. It is my privilege today to present to you the last examination preparation for our grade 12 learners. But before I start, I would like to address the grade 12s and I would like to wish them the best of luck for the exam that is coming. They've already started. I really hope that all your hard work and everything that you've put in here will be good for you and that it will help you to answer your questions and everything that is lying ahead of you. You've been in school for 12 years. This is your final stage. Please be disciplined and do your best. My presentation today will focus on the learners. Since the learners are not at school anymore, I thought that I would do this presentation for the learners. And that is why I've asked the teachers, please, colleagues, make sure that you send the links to the learners, that they can go through this presentation. The work that I'm going to do is the work that is not answered very well in our question papers. And I've asked one or two of my colleagues, and they've asked me to please look into quantities, and we're going to do that. That is the main focus of today, so we're going to look at quantities. Now, quantities is a question where you must make sure that you've got your calculator and everything ready. Bring it along on the day of the exam. It will be in question 2 as well as in question 3. So it's very important. Make sure that in question 2 you also do your calculations, and in question 3 there will also be quantities or calculations to be done. Mr. Tabayane, our DCS, in our previous presentation has done the layout of the question paper, so I'm not going to waste any time with that. The important part about that is that he gave you the allocation of marks for each topic or each question. Learners, I ask you please, do not look at the mark allocation and think, okay, this topic is only 4 marks, I'm not going to learn this whole chapter. Every mark counts and every mark is very important. Sometimes the work in one chapter goes over to the next chapter, so if you skip one chapter, you will definitely not know the work in the next chapter. So even if there is a mark allocation of like 4 marks for, say, doors, please do not decide not to learn the doors. Every mark counts. Okay, that said, there are Afrikaans-speaking learners in our group, and some of the schools have asked me, please, that I could, whenever it's necessary, if I feel it is necessary, some of the terminology that is in English, if I could repeat it in Afrikaans. So as I go along, I will do it in Afrikaans and English, mainly in English. But if I think that it is necessary to do a short 1 or 2 terminology phrases in Afrikaans, I will do that in Afrikaans. But please do not go away. It's not going to be a long Afrikaans session. It is only to help our Afrikaans learners. There are a few schools that is Afrikaans speaking, and they've asked me to do this. And I think it will only be fair to them as well. But my presentation in general will be in English. When we look at the quantities in the exam paper, in the previous papers in 2019 and 2018, that is the topic that is answered not very well. The learners struggle with the basic concepts. I've decided today that I'm going to step back to the basics. So the teachers, you will excuse me if I'm going back to the basics. This is actually for the learners. I see that in the exams they have difficulty in the units that is on the question paper. As you know, all the drawings that we do, whether it's a drawing of a model or a drawing of a house, is in millimeters. It is not in meters. So all the drawings and all the units that you will get on your drawings will be in millimeters. Sometimes the question asks you to give the answer in meters, and then you have to convert from millimeters to meters. And this is where the problem starts. The answers sometimes count 2 marks because they ask for it in meters. So if you give the answer in millimeters, you're going to lose the last 2 marks of each question. So let us make sure you can convert from meters to millimeters. That is very important. Read your question very, very clearly and make sure that you understand everything that they ask. If you look at the sketches, look at the whole sketch, look at every single line that is on the sketch, because the information on that drawing is very important. Just don't have a look and see this is the length and this is the height and there I go, I can work out the area. Make sure that it is the correct length and the correct height, because there will be a lot of heights and width and depth on your sketch, so make sure you are doing the right one. Okay, so now we can go over to the paper that I've prepared for you. I'm going to do quantities, and as you can see here on the screen, the following basics need attention. Number 1, the units used on a drawing will always be in millimeter. You will never get it in meters. The reason for this, learners, is because sometimes we have a small thing like a door frame that is less than a meter, so we can't work in meters. Otherwise, we will have a 0,056, and to do that, that just creates problems. So all our measurements on a drawing is in millimeters. They will not tell you that. You must know this by yourself. When volume and area are asked, the answer is usually asked in meter. I will explain it to you a little bit later so that you can understand that. So please answer what the question is asking. You can work it out in millimeters, but then we must convert it to meters. When covering a roof or a ceiling, the units that is used is in meter. So when they ask for the roof sheets, then you can answer in meter. You can say the roof sheet is 5,6 meters long. So we must be comfortable with doing this in millimeters and meters. Okay. So the units there, 1,000 millimeters equals 1 meter. That is basic stuff. We've been studying this from grade 8, so we know this. But the problem with these units are we are doing this on our calculators, and we really do not take a tape or a measuring or a ruler and we measure these things. So sometimes we struggle to convert it. Example there, 5,900 millimeters, the length of a garage, for instance, is 5,9 meters. Now, how do we get to that? There's a lot of things that your teacher have taught you, but I'm going to show you a shortcut. This is just for yourself, so that you will understand this a little bit clearer and that you will be able in the exam, if you struggle, to convert it. You take the 5,900, and we know that the unit, 1,000 millimeters, equal 1 meter. That gives us 3 noughts. Now, this 3 noughts is the crucial part here. We've got 5,900 here, so the comma will be behind the last 0 here. So you take that like 1, 2, 3 times. You skip 3 of these numbers there, and then you get 5,9. So any time you are going from millimeters to meters, you will use this method. Let us take 850. Now the 850 are the same here. You convert this to meters, the comma will be there at the back of the 0, and then from there you go 1, 2, 3, and your answer will be 0,85 meters. So make sure that you are comfortable with this, otherwise you're going to really struggle. I'm going to show you why this is important, and in this next sketch we've got this floor here. The length of the floor and the width of the floor is given. Because this is a plan, a ground plan, It is 5,900 millimeters and it is 2,500 millimeters. You will see that everything is in millimeters. Now they ask us in the question paper to work out the area. Now we know by now that it would be 5,900 times 2,500. Now that is easy to do. We take our calculator and we work it out. But now you can see the answer that we get here. It is 14,750,000 square millimeters. Now on paper this is working very well. But if you go to a shop and you would ask the guy there, you want to buy some tiles, and the area that you want to cover is 14,750,000 millimeters, you will not understand that. So we have to convert that to meters. If we work out the volume, it gets even more trickier. You will see that we've got the length times the width times the thickness of the concrete that we're going to do for the floor. So now it is 5,900 times 2,500 times 100. And you can see where we get there. That's 1,475 million cubic millimeters. Now that is a lot of zeros, and that is very confusing. So the best thing that we're going to do, we're going to take the 5,900 and we're going to convert it to meters, and the 2,500. So when we go back here, this length that we have here, 5,900, and the width there, 2,500, we're going to make it 5,9 times 2,5. And our answer will be 14,75 square meters. Vir die Afrikaanse leerders, hier is die oppervlakte of die area. So ons maak seker, ons werk dit in meters uit. Andersins gaan ons geweldige groot getalle hê wat niemand gaan verstaan nie. We start with the units before we work out our calculation. So do not wait after you've done the calculation to do the conversion, even if you have a calculator, because most of the learners are going to lose their marks for the answer. When we go to the volume, we do exactly the same. We take the 5,900, we convert it to meters, that is 5,9, times the 2,500, which is 2,5, and the 100 millimeters, which is 0,1. And we multiply that to get the cubic meters. Now, if you compare the two answers, you will see there's a huge difference. And the one in meters is much easier to work out. So let us just recap. Everything that is on this plan, if you're going to work it out and you're going to do like the area or the volume, please convert it before you do the calculation. Convert the millimeters to meters, and then you get your answer. Otherwise, you're going to struggle getting the answer later. Now, I've got an example here that we're going to go through. We're going to work out the quantities that is asked. Now, the question will be as follows. The figure below shows a building that has a gable roof. Study the figure and use the answer sheet to answer the questions that follow. Now, learners, you must read these questions very thoroughly, because I've highlighted this, study the figure. So if we look at this figure, there's a lot of information on this figure that we must study, that we must know. So let us see what information is given to us here. We know that this is a building. So those lines that are there, that is the lines of the building. In this case, it is a building without doors and without windows, because we do not need this in our calculation. It has not been hatched because the roof has just been taken off. If it was hatched, it means it was a sectional view, then it will have the hatching lines on it. But that part is our roof and our walls. The roof will be this dotted line that is going there. And this is basic stuff. We do this from grade 10 and you do it in EGD as well. The important part here is that you will be able to recognize the two parts. The one part being the walls and the other part being the roof. Now the roof is very important in this case. You must be able at this stage of your grade 12 year to know that that is a gable roof. The other roof that we are doing is a hipped roof. So when you're going to do your revision, please make sure that you do both the roofs. When we're going to work out the areas and the quantities that we use here, there will be a huge difference between a gable roof and a hipped roof. Let us just take the fascia board for instance. If we have a gable roof, the fascia board is only on the one side, that is overlapped there, and on this side here at the bottom. On the gable end of the roof, there is no fascia board. That will be the barger board. So let us make sure we know that. We can see here, let us study this figure, that it is 9,000 millimeters long. Now important that you will see, it is the outside dimension that we have here. From the outside of that wall, all the way to the outside of the next wall. The width is the same. This is the outside dimension from the one side of the room to the other side. Now why is this important? This is very important because when we're going to work out, for instance, the floor, the volume of the floor, then we need the inside measurement from there to here. When we're going to work out the fascia board, we're going to need the outside dimension plus the overhang. So it is important that we understand what is going on the sketch. It's a very simple sketch, but study, like the question tells us here, study the figure. Make sure before you start to answer that you understand everything. You will see here on the right that we have an overhang of 150 millimeters. They didn't give it on the left side here, but you know that the overhang on the one side is the same as the overhang on the other side. So that will also be 150 millimeters, even though they do not give it. We can see in the proportion of the drawing that must be the same. Okay, so let us go on. I've got a few examples here that I can show you. This is our gable roof. This is a good example of how it looks. This will be our elevations, say our north and our south elevation. And here we have a roof plan. The arrows here indicates the slope, in which direction the roof slopes down, in which direction the rain will flow on the roof. The dotted line in this case here is the walls on the inside, but they do not give us the width of the wall here. Here's another sketch where we can clearly see this is the gable end of the roof, so we call this a gable roof. When we move down, when we remove the sheets on the roof, the galvanized sheets, we will see that our framework, our roof trusses, will be exposed. Our roof trusses will be underneath our corrugated zinc or underneath our tiles. And when they're going to ask the question, it is important that we understand what is going on here. The part that is here in front, the beam that is going there, that is our wall plate. In Afrikaans noem ons dit die muurplaat. Dit is die gedeelte waarop die dakkappe rus. That is the part on which the roof trusses rest. So that wall plate will be on top of your wall and the roof truss will be on top of the wall plate. We've got one on the left-hand side and one on the right-hand side. Important here to know that it is only on the two sides where the roof is sloping. It is not on the head or the gable side of the roof. So there is no wall plate on this end of the roof. Important to know because they're going to ask you to work it out later. If we look at this house that we've got here, this sketch of the house, the ridge, that part that is there on top, die nok van die dak. Want hulle gaan vir ons die nokplate vra. They're going to ask us the ridge plates, and we must know that part. This is why the terminology, learners, is so important. Make sure you know the terminology of everything. The ridge plate will be on top there, and we're going to work that out. So the ridge is covered by a ridge plate. On the side here, that part here, that is where our fascia board will be. The reason for a fascia board there is to attach the gutter to, and the gutter will have a downpipe which will convert the water to the stormwater pipes and the stormwater drain. So that is the reason we have fascia board on this side. The water will not go here at the gable roof. It will flow down the roof and it will go into the gutter, and gutter will be attached to the fascia board. So that is important that we know that. I'm going to demonstrate this for you. Now you must take this sketch, keep it in mind, and you must take that one. And now I'm going to move back to the sketch which is going to be in the exam. Okay. I've got a lot of lines here, green ones. Let us start with the first one, the green one here. Now this green one is representing the wall plate. Now that is where my wall plate is going to be. So if they ask you that you must tell how long our wall plate is, you must know that the wall plate just goes from the one side right through to the other side. It doesn't go past there. That is important. The one will be on this side, and the other wall plate we're going to use is going to be on that side over there. So that are the two wall plates that we're going to use. The next one that they want us to know is the trusses. This is one truss here, and let us move a little bit up there. We start with our truss right here, and you will see that the truss is going against this gable end. There will be one here, and there will be a truss on the other side, a roof truss. So the other roof truss will be on the right-hand side of the sketch then. I'm going to put it in there. So that gives us the two main roof trusses, the one on the left-hand side and the one on the right-hand side. Then they will tell you that you must space them from center to center. Now, center to center means the distance from this roof truss to the next roof truss. In total, you have to work that out, and you will have to work out how many roof trusses there will be. So we've got the wall plates here, and on top of the wall plates, we've got the roof trusses. Right. The last two things that they're going to ask us to work out will be the fascia board. And the fascia board, boys and girls, learners, you will see will be at the end of the roof. So the fascia board will not be against the wall there, but it will be against this corrugated iron, and it will be at the end of the roof trusses. Now we will have two of them, the one on the one side, and the other one will be on the opposite side on the other side. So if you understand this, it is very easy. Let us just recap fast. The dotted part is our roof, and the other part is the walls. On the roof, we have the fascia board, and the fascia board will be there so that we can attach a gutter. So if you work out the length of the fascia board, you must make sure that it will go from the left side of the roof right onto the right side of the roof. So you'll have to add the 9,000 plus the 150 and the 150 on this side. But you must remember that there are two fascia boards. So in total, you'll multiply the answer by 2, because here are one of them and the other one is there on top. The wall plates will be from the inside of the gable to the inside on the right-hand side. So that is the easiest one. But in the sketch that I've given you here, I've given you the outside dimension. So when we're going to work out how long the wall plate is, we're going to take that 9,000 and we're going to minus the width of the wall on this side, and we're going to minus the width of the wall on the other side. The roof trusses, we're going to work out how many are there. So when you do this calculation, you know by now that you must add 1. So it is the length divided by the center to center distance plus 1. Now what does that plus 1 means? It means that we start with 1 here. And if we take the dimension from center to center and we divide it into the length, we will see that we will get like 12 or 10. That means that there are 12 openings. And it will stop there, and then we add 1 roof truss and we put it on the side there. Wanneer ons hierdie uitwerking doen, maak ons seker dat ons die lengte van die dak deel deur die center tot center spasiering wat hulle vir ons gee, plus 1 dakkap. So jy werk jou dakkappe uit en jy tel 1 ekstra dakkap by om hom op die kant te sit. You work out your roof trusses and then you add 1. So your final answer will be the calculation that you've done plus 1. I hope that is clear. I will come back to it a little bit later, but let us start with our calculation. Underneath our sketch, they will tell us, use the following specifications. Now, this is like a manual. We do not read the manual. We try to do everything on our own. This is very important. Use the following specifications. The walls are 220 thick because it is outside walls, and we're going to use that 220. The overhang of the roof at the gable ends, that is on the left and the right, are 150 millimeters. The center to center distance between the roof trusses is 1,300 millimeters. Let us just go back there. That means from the one to the other one is 1,300 millimeters. The last bit of information, specification that they give us, the ridge plates are 1,200 millimeters long. Now the ridge plates will be put on top, so the ridge plates will go from there all the way up to here. And by now, you will be able to know that the fascia board and the ridge plates, the length that they cover, are exactly the same. Right. Let's move over to calculate the following. Now, they will definitely not ask all of these calculations, but they will ask a lot of them. So let us cover all of them and let us make sure we understand what is going on. The first thing that they will ask is the length of the fascia. That is an easy one. We'll do that one now. The second one, the number of roof trusses needed. Now that calculation is a little bit more challenging, and we'll get to that one also. The length of the skirting. Now, boys and girls, learners, the skirting is on the inside. We know that the skirting is there to cover the opening between the wall and the floor. So in this case, where will our skirting be? So it will be inside this building. It will go from there on the inside all the way to there, all the way to here, back here, and to the end. The skirting in this case will be exactly the length that is the inside length of the building. Right. And the next thing that they're going to ask us here, the length of the wall plates, that is the green one, remember that one, and the total of ridge cappings needed. Okay, so that is a calculation that we're going to do. That is why they give us the ridge plates. So one ridge plate is 1,200 millimeters long, and they want the total of ridge plates that we're going to use. Ridge cappings or ridge plates, that would be the same. Now the first one that they ask is the length of the fascia board. You can do it in any way that suits you, that you are comfortable with. We take the length, the 9,000, and we add 300 plus 9,000 plus 300. Okay, so you can do it like that. Or you can take 9,000 plus 300 times 2. Or the next one is you can take 150 plus 9,000 plus 150 times 2. Then we will get our answer in millimeters because the units that we use there is in millimeters. That will give us 18,600 millimeters. Now we have to convert this to meters, and you remember we put our comma there at the back and we go 1, 2, 3. That would give us 18,6 meters. Okay. The next one that they ask us here, and this one is a little bit more trickier, the number of roof trusses needed. We take the internal dimension, and this is where we must be focused. And we divide it by the distance between centers. Okay. They give us that. They give us the distance between centers of one roof truss to the other one is 1,300. But that calculation there on top, that one, you must work out for yourself. So let us just go back and let us just see how do we work it out. You go from this wall, the roof trusses will be from here all the way to here. So we need the inside dimensions of this building. Now the outside dimension is 9,000. We know that this wall here is 220 and that wall is 220. So we take the 9,000 minus 440. So that is where our 9,000 is. That is 9,000 minus 440. That is the one wall on the one side and the wall on the other side. And then we get 8,560 divided by 1,300, which is the distance between the roof trusses. Now we convert this to meters. So we take that one and we take that one. That is 8,56 divided by 1,3 plus 1. You see, I put it there in red. You mustn't forget about that because that would be the last roof truss on the one side or on the other side. If we do our calculation, we will see we get to 6,58 plus 1. So the 6,58 becomes a 7 plus 1. So we will have 8 roof trusses that we're going to need on this roof of us. So let us go back and just make sure we work out the distance from the inside to the inside, from the gable end, this is the gable end, to the other gable end. Ons werk die afstand uit vanaf die een muur tot by die ander muur, die binne afstand, nie die buite afstand nie. So that is why we take the 9,000 minus 220 minus 220. That is very clear. I think you will all understand this. Then the plus 1. Do not forget that plus 1. Okay. The length of the skirting. Now the skirting is on the inside. In this case, we've got long walls and we've got short walls. The long walls is 9,000 millimeters long and the short walls is 6,000. So we minus the 440 and we minus the 440. That would give us 8,560 and 5,560 millimeters. If we go back to our sketch that we are looking at, the skirting, that is our long wall there. So if we work at that one, that would be the 9,000 minus 440, and there are 1, 2 of them. The short walls will be this one here, and the one on the other side. That would be 6,000 minus 440. And then we add them. Now you can use your own method. You can add 8,560 plus 5,560 plus 8,000 or you can use any other method that you are comfortable with. So let us look what we've done here. We've said 8,560 plus 5560 times 2. That gives us 28,240 millimeters. Or if the question says you must answer this in meters, you must convert it to meters. Again, the zero, after the zero there will be a comma, so we take that 1, 2, 3 spaces to the left, and we will have 28,24 meters. Now, why do we convert this into meters? Because in practice, we use meters. In theory, we use millimeters. If you come to a store like Builder's Warehouse or any of our stores, DIY, and you will ask the assistant there, you want 28,240 millimeters of skirting, he will definitely not understand you. So that is why we convert this into meter, because in practice, we're going to use the meters. That is the one method. The other method, you can just add the 2 long sides plus the 2 short sides, get the answer, and convert it to meters. The length of the wall plates. Now, this is the easiest one of all of them. Let us just go back and make sure we know what is the wall plates again. The wall plates will be this green line that is here and that green one that is there. This is the plate on which the roof trusses are resting. Again, you have to make sure, at first glance, we will just say, oh, this is easy. The wall plates must be 9,000 on this side and 9,000 on that side. But that would be incorrect, because we must minus this 220 here, and we must minus the 220 there. So it would be 9,000 minus 440. Let us look at our calculation. The long walls is 9,000 minus the 440, and that would give us 8,560. And what you must remember, there are 2. There are one on the one side, and there's another one on the other side. So you can just add those 2, or you can do the calculation like 8,560 times 2. Then your answer will be 17,120 millimeters. Or if the question says you must answer in meters, you convert it to meters. Now the ridge capping. This is a little bit more tricky here. Let us go back and let us make sure that the ridge capping, you'll see that is the ridge of our house, the roof, the ridge of the roof. The ridge capping will be the part that covers that ridge. The purpose of this ridge capping will be to close off the opening that is there. There's an opening there. When you put tiles or when you put corrugated iron sheets there will be an opening there. And to cover that opening so that no rain can come in, no dust can come in, no small insects can come into your ceilings or your roof area. So the ridge capping will be the part that we put there. Now the ridge capping, unfortunately, comes in certain sections. They make them like 1,300 or 1,200, and you must buy them like 5 or 6 ridge plates or ridge cappings, and you must just fasten them to the roof. In the more expensive houses that we have, they would come with a machine, and they will roll this whole ridge cap, and then they will cut it off. But 99% of our houses has ridge cappings, ridge plates, which is shorter. We will buy them at a certain length, and then we will cut them so that they will fit onto our roof. Now, how do we work that one out? Let us look at that. The length, or sometimes they will talk about the width of the roof, divided by the length of one ridge plate or one ridge capping. The length or the width of the long walls plus the overhangs. Okay, so in here you must make sure that you include the overhang. Let us look at what that part is. our roof from there to there will cover our house. But the part that goes beyond there, that is the overhang. Dit is die oorhang in Afrikaans. So daai gedeelte wat daar is, sowel as die gedeelte aan die linkerkant, the part on the left-hand side as well as the part on the right-hand side must be added, because our ridge plates go from the side here where the barge board is, all the way, it covers the ridge all the way up to the right-hand side. So we must make sure that we add the 150 here, and in this case they didn't give us 150 on the left-hand side, but we know and we can see that the overhang is the same. They indicate it here as well. So the overhang of the roof at gable ends is 150 millimeters. If they do not do this, if they do not give you the specifications, you, learners, must be able to deduct from this sketch that this 150, this distance here, and the distance on the left-hand side are the same. So sometimes that will be a high-order question, and they will leave that out. They will only give you the distance on the one side. Then you must be able to know that the distance on the left-hand side and the right-hand side are the same. Right, so we've got that. Let us go back to our calculation. Total number of ridge cappings. Right, that is the 9,000 plus 2 times 150. Overhang on the left and the overhang on the right. Right, and we divide it by the length of a ridge plate. In this case, the length of this ridge plate we are using here is 1,200 millimeters. So it is 9,300 divided by 1,200, which would give us 7,75 ridge plates. But that is not our final answer. As you know, we cannot go and buy a certain part of a ridge plate. So we have to buy the whole ridge plate, cut off the part that we use, and then we will throw away the offcut. So we will go and buy 8 ridge plates. So make sure that in your final answer, you take that 7,75 and you make that 8. Even if this would be 7,1 or 7,01, we will still buy 8 ridge plates. Your answer must still be 8 ridge plates. That is very important. Then you can, the last part, the last small part, you will cut the last 2 ridge plates a little bit shorter so that we do not have just a small little part that is sitting on the end. So then we can cut 1 or 2 of our ridge plates a little bit shorter, because you can't fasten a ridge plate that is that short. Okay. So let us just recap this one then. The length of the long wall plus the overhang on the left-hand side and the right-hand side. You add those two. And then you look in your instructions. It will be given there. What is the length of one ridge plate? In this case, it is 1,200. So we take the 1,200, divide it into 9,300, and we get the 7,75. And learners, this is not millimeters or meters, ne? This is ridge plates. So you must write it there. The columns that we use, as you know, the one on the left-hand side is for the quantity, column number A. Column number B will be for the calculation. Column number C will be for the answer. And column number D will be for the explanation. In this case, we do not need to use column number A, B, or C, because it doesn't lend it to this A, B, and C. We can work it out in column number D. But we must write here ridge plates. Right, let's just go back and just recap. Let us make sure we are on the spot, because these things are going to be in the exam. I hope so. One of them must be there, and this will be easy marks for you. The fascia board will be on the outside, so that would be our 9,000 plus the 300. And remember, there are two fascia boards, the one on this side and one on the opposite side of the house. So that is why we have a 2 there. In this case, make sure that what they ask. In this question, they've asked, give the answer in meters. Now, you will see that we've got one tick here. So that tick is for this whole calculation. And then you've got the answer here, 18,600, which is 100% correct. But since the answer must be in meters, the 2 ticks will be here. So even though you can do this calculation 100%, you will only get 1 mark out of 3 because you did not answer the question. The answer to this question would be 18,6 meters. 1 tick for the answer and 1 tick for the unit. And this is where a lot of learners lose a lot of marks. They are in a haste, they are going very fast, and they do not read the question properly. Even though when you go out of the exam hall, then you know, oh, everything went well, but you were not reading your question. So make sure, you will see here, 1 mark there for the whole calculation, because this is an easy calculation, and 2 marks there for the answer. The answer is 1, and the unit is the other one. Right, the number of roof trusses. This one is also easy. It is the length there, and you must remember that the roof trusses are on the inside. So we minus the 440 to 20 of each wall, and we divide it then by the space between the roof trusses, the center to center space. And we must add that 1 there. You get the answer plus the 1, and then you write there again, roof trusses. So you must tell us what this is. Right. The length of the skirting, this one is easy, it's just in millimeters, so there's no problem about that. And this is the inside. The only catch here is that you must make sure that you minus the wall on the left and the right, and the short wall on the left and the right. If in this case, in 90% of the sketches you will get, there will be a door. So when you get the answer, like 28,24, you work it out like this, and then you minus the width of the door, which on a sketch will be 0.9 meters. So make sure, if there is a door, that you subtract the door from the total length. The length of the wall plates, they are the same, they are on the inside. So you take the outside dimension minus the 2 walls, and you'll get the answer 17,120, or 17,12 meters, or 17,120. The number of ridge cappings, you take the width of the roof divided by the length of the ridge plates, and then you get an answer there. If it is 7,00, then it stays 7. If it's 7,1, it goes to 8. Let us make sure about that. The next thing, the analytical question. This is just for information. Learners, make sure. In the past 2 or 3 papers, they've asked a floor plan, and they've asked a south, north, or east elevation. But if you go to your graphics and design in your book and in your CABS document, they will stipulate that a site plan can also be an analytical question. So make sure that you are on top of this. On page 43, you must write that down, page 43 in your book, your textbook, there's a very nice example of a site plan that can be asked, with all the rodding eyes, the inspection eyes, the wash basins, and everything is there. So make sure. One thing that I would like you to do, when you get a sketch like this, and you get the north sign here at the bottom, take your pencil and immediately, north is in this direction. So north will be here. So you write there north, like N, do that immediately. North there, then you move to the right, north, east, you write east there, you go to the bottom, south, and then you write there, west on the left-hand side. Because a lot of the questions is like, on which side of the site will you find the septic tank? Or on which side, on which elevation of the site plan will you find the public sidewalk? Then you can't say in front or the left. You must indicate that by the northern side or the south side or the west side or the east side. So make sure. And do not get confused by this north sign here. This is not north. North is there at the top. So immediately put your north there, your east, your south, and your west. This is the elevation and floor plan we are accustomed to. We know this one. A few things that I want to highlight here that we must make sure of is this number 7. This number 7 do not indicate this barger board here. So make sure that you understand this arrow here. This means the opening between the end of this barger board and the wall. So that is our overhang. Now a question that can come from this is, what type of overhang is this, an opened or a closed eave? So this can have two answers. Make sure you understand that one. The next one I want to show you that is important is this window. You will see these dotted lines here, and they are there for a reason. So make sure you read the question. Is this arrow indicating the window? Is it indicating the opening? So this is the direction. The handle will be there in the center. So this is a common mistake that we make. This number 2 here, that is a down pipe. That is not a gutter. The gutter are the small little part that is on top there. A lot of marks get lost here. So make sure you know that is the gutter. Number 5, this can have two names. This one is, in this case, this is a door opening because no door is here. If this would be an outside door, they would indicate it here, like the symbol for an outside door. In this case, this will be a door or a door opening. Make sure that you know the abbreviations, like number 8, final floor level. Make sure you know that. When you go to the ground plan, the floor plan, again, we've got this north sign here. So when you do this, go up here and write here on the top. Write north, on the right, east, south, and west. The question will be, in which direction does the steps lead? Then you will say it will lead in a northern direction. So it's important that you know where is which north, east, south, and west. The rest of the exam of the graphic design part of the exam will be drawing sketches, which you know already. Make sure if you draw a sketch, do not waste time to use your ruler if they ask you to draw a freehand sketch. So quantities, in this question, question number 2, there will also be quantities. They will ask you to work out the volume or the perimeter. So make sure if they ask the perimeter that you will know that this is the inside dimension. You must add that 220 on this side, 220 on that side. So when you go to this north, east, south, west elevation, you must add the 220 here and there as well. So that will be a lot of walls that you're going to add. Make sure that you do that. Right, the last thing that I want to, my time is up, I just want to do this door with you. This is a very easy question. The doors that are there, we understand doors, we see doors every single day. So let us make sure that we've got this covered. Make sure that you know the specific terminology. If they've got a hinge here, this style will be a hinge style. Make sure you know where is the lock. Then you'll have a lock style. Like you've got the lock rail here because the lock is situated there. Learners, make sure you know the difference and you can give me the advantages of this door and that door. Make sure that the framed, ledged and braced batten door that is here, you know the difference, why you would use the one or the other one. Make sure you will be able to label them and where they are used. Now that concludes my last examination preparation. Thank you for the privilege of being able to do this. I wish you the best of luck, and I know you're going to do good. And with this exam and your PAT that you have finished, you will definitely get a good mark, and the best of luck for all the teachers and all the guys that's going to mark at the end of the year. I really hope that your candidates do good and that you are proud of them. Thank you very much.